and gentlemen, welcome to lesson 10.2, page 408, and of course, you have read page 408 and 409, and you've taken a few notes on probability. Today we're going to compute the probability of an event. Our essential question, how can you describe the likelihood of an event? So, we got to know, what is probability? And you wrote it down. And hopefully you wrote down that probability is the likelihood that an event will occur. It's the likelihood. And so they gave you this nice, wonderful chart. And so did I. This nice, wonderful chart that shows that probability goes from 0 all the way to 1. Meaning it's impossible to happen, all the way to it's absolutely certain it will happen. And in between 0 and 1, we have different likelihoods. And we also notice a couple other things. That probability is written as a fraction, right here. Probability can be written as a fraction. Probability can also be written as a decimal, right? Decimal. And probability can also be written as a percent. Well, we use fractions and decimals. Fractions and decimals, these right here, that's how we do math. That's how we do math with probability. As a percent, this is how we talk. You're always hearing percents. They throw percents out all the time on TV and in newspapers and magazines, and they always give probability as a percent. Hey, there's a 50% chance that it's going to rain tomorrow. You hear that on the weather all the time. Well, that's probability. So the likelihood that an event will occur between 0 and 1 to include 0 and 1. And then when we want to use a mathematical term to let us know, hey, we want to find the probability of an event. Probability is a capital P, and then inside parentheses, we would put the event, whatever that event might be. Let's say we're picking a number between 0 and 1. If I'm picking a number between 0 and, let's go 0 and 10. We're going to pick a number between 0 and 10, and I want to know, hey, what's the probability of picking a 4? That's how I would write it, with a capital P, and inside the parentheses, what is the outcome I want to know about? All right? So that is probability, something we need to know. So we're going to spend this first video and we're just going to describe the likelihood. This is going to go real fast. So we're going to refer back to that chart. We're going to refer back to that chart when we're describing the likelihood of an event. And this goes pretty quickly. There is a 70% chance of thunderstorms tomorrow. In example 1, we're going to describe the likelihood of this event happening. So when you look at your chart, you see that right down the middle there's 1 out of 2, which is 1/2, or 0.5 or 50%, which is equally likely. And then you have in between 50% and 0, which is unlikely. So that's 1/4, 0.25, and 0.25. And of course, if you fell either side of that, you would want to use words to phrase it appropriately. And then we have on the upper side of 1/2, at 75%, or 0.7534, you have likely. So 70% falls just short of that 75% likely. So you could say likely to rain. It's close enough to 75 that you can say it's likely. Okay? If it were over 75, say between 75 and 99, you would say highly likely or very, very, very highly likely as you're getting closer and closer to 1. Example 2, a professional baseball player is batting 0.325. That's how they mark down batting averages in baseball. Describe the likelihood that the player will get a hit his next time at bat. Well, using that decimal, that falls just above unlikely, because 25% is 0.25. So he has it just about, or she has it just a little bit more. So I'm probably still going to use unlikely to get a hit. However, if a batter in baseball bats that, if a batter is unlikely to get a hit in baseball and by batting 0.325, that player is making a lot of money. How interesting. That is the one sport where they get paid a lot of money and they fail over half the time. Over half the time. Nobody has ever in the history of baseball had 50% success in going up to bat and hitting the ball fair. In fact, 40% is very, 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 very rare. Only a few players have done that. So they pay those baseball players a lot to fail. So you might want to become a baseball player. Number 3, you pick a number from a deck of cards numbered 1 to 10. Describe the likelihood that you will pick an even number. Well, we have even numbers of 2, 4, 6, and 8. We have odd numbers, and 10. And we have odd numbers of 1, 3, 5, 7, and 9. So that looks about 50-50 to me. So it's equally likely. Very good. Our next one. A pack of M&Ms has 3 green, 2 yellow, 5 brown, and 3 blue M&Ms. For a total of 3 plus 2 is 5, plus 5 is 10, plus 3 is 13 M&Ms. Describe the likelihood that you will draw an orange M&M from the pack. What? Orange? Wait a minute. We have green, yellow, brown, and blue. There's no orange. So what's the likelihood? Yeah, impossible. Not going to happen. You're not going to pull an orange M&M from that pack of M&Ms. And the last one. There is a 100% chance it will not rain tomorrow. Describe the likelihood it will not rain. So here we have not, that complementary event. So the probability that it will rain, let's just write rain, would be 0%. Plus the probability of not rain, that's 100%. Well, when you add those two together, you get 100%. As a decimal, that's 1.0. So that's 1. Probability of complementary events is equal to 1. Well, anyway, so the probability it will not rain is 100%. So that means it's certain. It's going to happen. It's going to rain tomorrow. Ladies and gentlemen, our first quick write. And again, like the last video, you might want to pause this so you can answer them all. We have a bag with these same figures from before. And you are going to describe the likelihood of randomly drawing some of those figures from the bag. Ladies and gentlemen, when you're done, take a quick break. Stop your timer. When you come back, start that timer up again. Get yourself a nice break. And I'll see you in a few minutes. Bye.